Hi there. Let's start this video out by taking a look at a typical quadratic equation. Now if I solve this, the first thing I'm going to look at is, can I factor it? Are there two numbers that multiply to give me 7 and add to give me 3? The answer is no. So it looks like I'm going to have to use the quadratic formula. And when I do that, I need to first pick out my A, my B, and my C. Here I've got A is 1, because if there is no coefficient we know it's a 1, B is 3, and C is 7. Now let's put it in the quadratic formula and work it out. Now if you look at this equation and how it's been worked out, you see down here that we end up with a negative number underneath the radical. So if that's the case, we have no real solutions. Now it might be helpful to be able to tell how many solutions and what kind they are without actually having to work the whole thing out. And what happens is that we can do that if we look at the number that shows up under the radical. That number is called the discriminant. The discriminant is the number that we get from the quadratic formula that is underneath the radical. So if you look at the quadratic formula, which we've used numerous times, the part that is underneath the radical, which is b squared minus 4ac, that's the part that we call the discriminant. So the discriminant is b squared minus 4ac. Okay, here I have 4 separate quadratic equations that I've solved all by using the quadratic formula. The first one, you can see by the final answer that I get 2 solutions, and because I have this radical, I know that they are irrational. Over here, I got 1 solution, and the reason I got 1 solution was because I ended up with a 0 under the radical, which made this whole term drop out, and I just got 6 over 2. That solution would be rational. Over here, because there's a negative under the radical, I do get 2 solutions, but they are complex. They are not real solutions. I get 2 complex solutions. I should make a note over here that if it's rational, it's always real, and if it's irrational, it's also real. Complex are numbers that are not real numbers. Now over here, I end up with, because I had a perfect square under the radical, I ended up with 2 solutions, and they were both rational. So I get 2 solutions, and they are rational because there are no radicals involved, and of course that means they are also real. Now in Algebra 1, anytime you saw a negative number under the radical, you just wrote no solution. Well, that's partially right. There are no real solutions, but there are 2 complex solutions, and we'll work on those a little bit more in the next chapter. So now I've taken off the actual solutions and the entire quadratic formula, but I just am going to look at the discriminant. That's the part that's under the radical. So if the number under the radical is a number like 32, I'm going to get 2 solutions, but they're going to be irrational because the 32 is not a perfect square. I can simplify radical 32, but I can't get rid of the radical totally. Now over here, if the discriminant turns out to be 0, that means I'm going to have only 1 solution, and it's going to be rational. If the number underneath the radical is a negative 23, or any negative number, that's when I get 2 complex solutions. And if it's a perfect square, I get 2 solutions, and they're rational because I know the square root of 36 is 6, so my answer will not have any radicals in it. So here's kind of the summary. In general, if your discriminant is greater than 0, which means positive, you're going to get two real solutions. If that number is a perfect square, they're rational. If it's not a perfect square, they're irrational. If your discriminant equals 0, you're going to get one real rational solution. And if it's negative, which means less than 0, you're going to get two complex solutions. As a closing comment on this video, let me just encourage you to remember that b squared minus 4ac is what we call the radicand. It's the number underneath the radical. Oftentimes, when I ask students to tell me the discriminant, they leave the radical sign on there, which is incorrect. So on an assignment or on a test, if I ask for the discriminant, just calculate b squared minus 4ac. Leave the radical off. The discriminant is the number that's under the radical because that's what gives us the number of solutions and what is called the nature of solutions. You can tell me how many there are, but I also need to know the nature. What kind? Rational, real, complex, irrational? And those you can tell by looking at the type of number that is underneath the radical. Let's look at just a couple examples. For this problem, if I'm going to look at b squared minus 4ac, I take negative 3 squared, which is 9, minus 4 times 1 times 2, so I get 9 minus 8, which is 1. All right, the number 1 is a perfect square, and it's positive, so I know that I've got two real, rational solutions. For the second one here, if I do the same thing, I'm looking at b squared minus 4ac. b is 5, so b squared is 25, minus 4 times 2 times 10. 25 minus 80 is a negative 55. Now that's a negative number, so that tells me that I have two complex solutions.